So, let's continue our construction. We will move on to the processing of wooden structures in this module. But first, let me show you the scheme to remind you what we have done so far. We have already constructed the metal structures, creating non-standard parts. Now, let's talk about how original parts are constructed, those that cannot be standardized and must be created according to the specific situation. This step is crucial, as these parts must fit precisely into the overall skeleton context. Later, we will systematically review how standard blocks are constructed and how they are adapted to the existing context. Constructing decorative glass and countertop. So I will now demonstrate how these parts are constructed. At the same time, we will discuss the application of materials in our construction process. We continue our progression from where we left off, the generation of metal structures. Now let's turn off these bodies as they are no longer needed and continue our work. First, we will create bodies that will represent the decorative glass construction at the front. To do this, we will use the dress up command. To make it more convenient, let's rotate the model from the other side and assign a plate to the skeletal body, which will be made based on the given surface facing inward. We select the parameter required for this plate's production, which comes from a higher skeletal level. As we can see, the plate has been produced, and the next step is to create the glass. Selecting another plane, this time it will be produced outward. We also determine the parameter that specifies the thickness of the glass. Next, a countertop is needed. For the countertop, we specify the surface on which it will be supported and the direction in which it will go inward. We also select the parameter that determines the thickness of the countertop plate. Just like that, we have constructed these non-standard components. Converting bodies into parts. Let's proceed to converting the bodies into parts. For convenience, these bodies will be renamed their future part names. To create the parts, we simply select these bodies and use the Make Components command. These parts will be placed into wooden structures under a specific name and positioned in Block 2, Wood of Block 2. This way, we have designed the required parts. Material assignments and BOM review. Before continuing, we want to navigate to the Woodwork for Inventor section. Here, the Woodwork for Inventor BOM generator tool is launched. As we can see, the generator is currently empty and does not display any entries. Let's try assigning materials to the components and see what changes occur. For example, we assign laminated board to the countertop, particle board material to the supporting plane, and glass panel to the glass. Now, let's check what the BOM generator shows. We immediately see 3 parts to which Woodwork for Inventor material has been assigned. Let's look at the data of one part. We see that it consists not only of the part itself and its dimensions, but also includes the workpiece and its dimensions. Now let's assign a coating to the countertop part, let's say a 2 mm thick layer. By assigning the coating, we embed it into the part model. The BOM generator immediately shows that the workpiece has become 2 mm narrower than the countertop. If we need to assign additional allowances for technological reasons, we can do so in the Woodwork for Inventor environment. For example, in terms of length, we add 10 mm on both sides. Checking the BOM tool, we see that the workpiece length has increased by 20 mm. What happens if we need to change the texture direction for some reason? We select the Align by Edge function. The dimensions change because a new piece of material needs to be cut. And this is also reflected in the generated report. If we do not need to change the texture direction, we can restore it to its original state. Working with multilayer panels. Another important aspect is complex products where certain panels cannot be purchased and must be manufactured by gluing multiple boards together. These are called multi-layer panels. For example, we need to make the countertop from several boards. Woodwork for Inventor allows the creation of necessary material configurations both in advance and dynamically. For example, by default, we see that we have a material made of 2 particle boards with a thickness of 50 millimeters. However, by reading the model data, we see that our board is 37 millimeters thick. We temporarily name it countertop material. Then, we add a top layer of veneer and a bottom layer of paper film. The constructor automatically calculates all possible layer thicknesses based on the total board thickness. Checking the specifications, we see that this part consists of layers of veneer, 2 MDF boards, and paper film at the bottom. We can be sure that these materials will be accounted for in all reports. Thus, we have completed important construction steps and configured the necessary materials, ensuring their precise application in our project.